Good afternoon, everybody. Welcome back to the backyard. It is good to be here, good to be with you. And today, for this lesson on assigning oxidation state to elements. So what we're going to do today is we're going to learn the different rules that we have in chemistry to assign an oxidation number. The whole idea here is for us to be able to say, in the end, after you're looking at a chemical reaction, then we can say which element is being reduced, which element is being oxidized, and what that's going to allow us to do is to calculate the voltage that is generated by a chemical reaction. So this is all part of our chapter on electrochemistry. Electrochemistry, so we're doing chemical reactions, and what's happening is that in the chemical reaction, there's an element that is losing electrons. These electrons are sent through the wire to the other element. So you've got an element being oxidized. It loses the losing electron oxidation, right? Leo the lion goes grr, gain electron reduction. So we've got one element on one end, on one half cell, that is losing the electron. These electrons are carried through the wire to the other element, which is gaining the electron, being reduced. So there's going to be like a potential difference between these two elements, depending on what element we're using. There's going to be a potential difference between the two elements, and that's what the voltage is going to be. So we're going to be able to measure this voltage without even doing the chemical reaction or without doing the cell. We'll be able to predict what the voltage is going to be. So this is super important. This is an exciting topic of chemistry. It's kind of a combination of chemistry and physics all together. And it's of course, it's super important right now as we're developing electric automobiles and all kinds of stuff that use electricity and chemicals in cells, in batteries. So this is what electrochemistry is all about. So the first part of this is to be able to identify the elements that are being oxidized, the ones that's losing electrons, the element that's being reduced, gaining the electrons. And from that information, in the next unit, in the next lesson that we're going to do, and coming up just a little bit, we'll be able to calculate the voltage. All right, so if we're looking at your notes, and I'm sharing my screen here. So we have the rules for assigning oxidation number. I know, 7 rules, right? It's okay, it's not very complicated. Most of these rules are very, very, very simple. So I'm gonna go over the rules with you. We're gonna do a little bit of highlighting here and there. Okay, rule number 1, super easy. If you have an element that's by itself, right, just a pure element, not combined with anything else, the oxidation number is 0. All right, so very simple. So the oxidation number of an element and its free state is 0. Now remember, some of the elements though are diatomic, right? Like oxygen is O2. Well, O2, that's the element oxygen uncombined with any other elements, right? That's how it exists in its free state. It's just normal state as pure oxygen is O2. So if you see O2, that's 0. Any element by itself, uncombined, 0. Also applies for sulfur, which is kind of weird, right, as S8. But one element by itself, 0. Okay, rule number 2. If you have an atom in an ionic compound, if you have an atom in a compound and there's only one of that atom, right, that oxidation number of that element is the same as the charge on the ion. So think like sodium chloride, okay? NaCl. There's one Na and there's one Cl. It's an ionic compound. The oxidation number on Na is the same as the charge on the Na ion. So the sodium ion on the periodic table, 1+. So the oxidation number, 1+. That's simple. So the oxidation number, when you have one atom, it's the same as the charge on the ion. Rule number 3, whenever you have a compound, right, then the sum of all of the oxidation number is 0. So if we had like water, H2O, so there's 2 H's and then there's 1 O, the oxidation number on the H's and on the O, they're going to add up to 0. Always. So a compound, the total number is always 0. Rule number 4. If you have an alkali metal, that's 1 plus. Anytime you have an alkali metal, the oxidation number, 1 plus. Easy. Alkaline earth, 2 plus. That's the same as the charge on the ion, right? Okay, so this is very simple. Oxygen, 2 minus. Again, same as the charge on the ion. Now there's an exception to the oxygen rule, is that if it's in a peroxide, then the charge is 1 minus. But when it is in a peroxide, well, either the name will say like hydrogen peroxide, but the peroxide is a group of 2 oxygen with a 2 minus charge. That's why each oxygen is a 1 minus. So oxygen in a peroxide, 1 minus. Oxygen any other time, 2 minus. So needless to say, oxygen is usually 2 minus. Hydrogen, 1 plus. Now there's an exception to hydrogen as well. When hydrogen is in a compound as a hydride, like for example, potassium hydride, or lithium hydride, calcium hydride. So in that case, the hydrogen is, if you say you have calcium hydride, whoops, say you have calcium hydride, which is CaH2. You see the hydrogen is in the non-metal position in the compound. It's second. So in a case like this, the hydrogen is a 1 minus, which kind of makes sense because it's in the non-metal position, which would have to be a negative charge, right? When the hydrogen is in the metal position, like it usually is, then it would be a 1 plus. So hydrogen, 1 plus, unless it's paired second to a metal. Last rule, fluorine is always 1 minus. So is chlorine, bromine, iodine. So the whole family of the halogen metals, right? 1 minus. The only exception is when chlorine, bromine, and iodine are paired with fluorine or oxygen. Fluorine and oxygen would be fluorine and oxygen would be the negative element, and then in the case like that, then the chlorine, bromine, or iodine would be a 1 plus, because the electron affinity for hydrogen and oxygen is higher than chlorine, bromine, and iodine. So it's always the fluorine or the oxygen that are going to receive the electron. Fluorine receives the electron no matter what. Right? You know, it's this most electronegative element, right? It's the one with the greatest electron affinity. So fluorine always gets the electron. Fluorine is always 1 minus. Oxygen usually will receive electrons, and it will be 2 minus. All right. I know it seems like a lot of rules, but it actually, let's do some examples, and it's going to help you. So this sheet you have, I've included in your weekly assignment. So it's the oxidation state worksheet. So I'm going to do these problems with you. I'm going to actually start with number 3, zinc oxide. So let's start with this over here. So this zinc oxide, the charge on the whole compound is always equal to 0, right? So that means that the zinc, which is a metal, will be positive, and oxygen is it would be negative. They're going to have the same charge. They have to add up to 0. So in this case, we know one of the rules is that oxygen is always 2-, unless it's a peroxide, right? This is not a peroxide. It's not zinc peroxide, right? So the oxygen we know is 2-. So since zinc oxide has to be 0 and the oxygen is 2-, the zinc has to be 2+. That's it. All right. NH3. So remember the rule for hydrogen is that it is 1+, unless it's paired with a metal. In this case, it's paired with nitrogen, so nitrogen is not a metal, right? And so therefore, hydrogen is 1+. Well, so what is nitrogen going to be? There are 3 hydrogens, so that's 1+, 1+, 1+, which gives you a total of 3+. Since the whole NH3 is 0, the whole compound is always 0. Well, that tells you that nitrogen has to be 3+. Sorry, 3-. So nitrogen is 3-. Hydrogen is 1+, 1+, 1+. Total is 0. Sodium nitrate is a little bit tricky because it has nitrate in it, which is a polyatomic ion, right? So sodium nitrate is going to be a total of 0. Na, we know this is an alkali metal, first family, and one of the rules is that alkali metals are always 1+. The other rule is that oxygen is always 2-, unless it's peroxide. Well, so if oxygen is 2-, there's 3 of them, right? So 2-, 2-, 2-, that's 6-. Your Na is 1+, so the nitrogen has to be 5+. So 1+, 5+, that's a total of 6+. And then 2-, 2-, 2-, that's 6-. So the whole thing is equal to 0. And that's how you do it. So you just follow the rules. Number 5, hydride. So remember the hydrogen is always 1+, except when it's a hydride, it's a minus. All right, let's scroll this down to number 11 here, because this is what we're trying to do. Ultimately, what we're trying to do is to get these numbers, these oxidation numbers, in the chemical reaction so that we know which element is being reduced and which element's being oxidized. So we're going to do what we just learned, except that we're going to look at it in the context of a chemical reaction. Oxidized, O, right? So this is LEO. Lose electron oxidation. So the element oxidized is the element that's losing the electron. The element being reduced, GER, gain electron reduction. The element that's being reduced is the one that's gaining the electron. All right, so what we're going to do is we're going to look at the chemical reaction, and then we're going to assign numbers, and then we'll look at what's happening to each one. Calcium, hey, there's a rule for that. An element in its pure, uncombined state. 0. The oxygen rule is that oxygen is 2 minus. Hydrogen is always 1 plus. And you see this works because 1 plus and then another 1 plus, that's 2 plus, and a 2 minus. So the charge on the whole water is 0. On the other side, the rule for oxygen is that oxygen is 2 minus. So since CaO is 0, that means that Ca has to be 2 plus. And hydrogen is an element in its pure state, uncombined. So hydrogen is 0. So what's happening here? The calcium is changing numbers. Calcium is going from 0 to 2 plus. So how does an element acquire a 2 plus charge? By losing 2 electrons. So the element that's being oxidized, the element that lost electrons, is calcium. Calcium lost 2 electrons and became calcium 2 plus. The oxygen doesn't change. The oxygen was a 2 minus and it still is a 2 minus, so nothing's happening with the oxygen element here. The hydrogen goes from 1 plus to 0, so the hydrogen started at 1 plus and ended up at 0. So in order to go from a 1 plus charge to neutral, right, to 0, it has to gain an electron. So the element that's being reduced is hydrogen. Now you might be thinking, wait a second, this calcium here is losing 2 electrons, but the hydrogen is only gaining 1. What's happening to the other electron? Well, look at the equation here, and you'll see there are 2 hydrogens, right? So each one of those hydrogen is going from a 1 plus to a 0. So each hydrogen is gaining 1 electron. Calcium is losing 2, one hydrogen picks 1 up, and the other hydrogen picks the other 1 up. So now you see why it was important in the first step to learn how to assign numbers. So again, we're learning these rules for assigning oxidation numbers so that we know which element is being oxidized and which element is being reduced. And again, the purpose of that is for in the lessons to come, what we're going to do is we'll be able to look at these half reactions, the calcium losing 2 electrons, the hydrogen gaining an electron, and from that information, we'll be able to calculate the voltage, right? That's the ultimate goal, is to be able to calculate the voltage that is generated from this. So I'm going to scroll up here to the next page, and and what we're going to do, I know that it says to balance here, but there's no need. Right now, what I would like us to do is to be able to focus on assigning the numbers and being able to see what's being oxidized and what's being reduced, right? So we're going to do these problems here like the one that we just did. We're going to look at the equation, we're going to assign the numbers, and we're going to identify the element being oxidized and element being reduced. So iron plus zinc chloride gives iron 3 chloride plus the zinc. An element in its pure form, uncombined, like the iron right here, this is 0. The rule for chlorine is that it is always 1 minus unless it's paired with oxygen and fluorine, which in this case it's not. The zinc chloride together has to add up to 0. Chlorine is -1. There's 2 of them, so the zinc is 2 plus. On the other side, we can identify right away the zinc as being an oxidation number 0 because it's uncombined. So anytime you have a pure element by itself, always 0. The rule for chlorine still applies. Chlorine is always -1 unless it's with oxygen or fluorine. And then the iron, then if this is 0 and there are 3 chlorines, then the iron has to be 3 plus. So this reaction, we can see the iron goes from 0 to 3 plus. So to do that, the iron has to lose 3 electrons. So iron is being oxidized. Lose electron oxidation. The chlorine stays at 1 minus. The zinc goes from 2 plus to 0. So the zinc had to gain 2 electrons. Gain electron reduction. So the zinc is being reduced. Well, it's actually the zinc 2 plus that's being reduced. Right? So the zinc 2 plus is being reduced to zinc, and iron is being oxidized to iron 3 plus. So this is it. The rules for assigning oxidation numbers to elements. 7 rules. Right? And if we look at these 7 rules, just to review, if the element is free element in its uncombined state, if the element is just by itself, it's always 0. Keep an eye out for the diatomics. Rule number 2, if you have an element that's in an ionic compound and there's only one of that element, then the oxidation number is the same as the charge. So sodium chloride, sodium, 1 sodium, so that's charge of 1 plus, like the sodium ion. The sum of the of all of the oxidation numbers in a compound is always 0. The alkali metal, always 1 plus. The alkaline earth metal, always 2 plus. So first family in the periodic table, 1 plus. Second family in the periodic table, 2 plus. Oxygen, 2 minus. Unless it's peroxide, very rare, but it would be 1 minus then. Hydrogen, 1 plus. Unless it's a hydride, very rare, but then it would be 1 minus. Fluorine, chlorine, bromine, iodine, the halogens, 1 minus. Fluorine, always 1 minus. The other ones, chlorine, bromine, iodine, they're always going to be 1 minus unless they're paired with fluorine or oxygen. Oxygen is 2 minus, fluorine is 1 minus. I hope this helps, and with a little bit of practice, you're going to get this. So have a great week. I'm looking forward to our next lesson on calculating voltage. Sounds good. Have a great week, everybody.